Hello, welcome to Shivin Solution. In this video, we'll discuss 2020 Jam Chemistry question number 1 to 10. Okay, let's start. Actually, exam was pretty easy, so I hope everyone scored good marks. Let's see how to solve the questions. Okay, so this is the question number 1. The reagent required for the following transformation. So if you look at the question here, you can see it here. In this particular question, one C double bond O group, carbonyl group is converted to C double bond CH2, okay, two hydrogens. So this is what happened here. So if you look at the options, you can see sodium borohydride is a H minus donor. So it will attack here, okay, and it will convert ketone to alcohol. That is the role of sodium borohydride. Okay, sodium borohydride. Actually, it's a weak reagent. Lithium aluminum hydride also provide the same H minus, and it also convert the carbonyl group. Compared to lithium aluminum hydride, sodium borohydride is a weak reagent. Usually, sodium borohydride is used for the reduction of aldehyde. Lithium aluminum hydride is the best reagent for the conversion of carbonyl ketones. But what happens if you use this reagent? It will convert carbonyl group to alcohol, not C double bond CH2. Okay. TH. Next reagent, third reagent is boranes B3H3 B3H. Sorry, BH3. Boranes. What is the role of boranes? If you have carbonyl groups, means carboxylic acid. Okay. This boranes convert carboxyl, reduction of carboxylic acid happens. Okay, carboxylic acid will be converted to alcohol. That is what happens if you use option C. So for this particular reaction, for the conversion of carbonyl group to CH2, first reagent is this one, option B. This is Clemenson's reagent. Okay. Option D is the correct answer. Now for the second question, if you look at the questions, you can see the reaction is like this: major product formed in the following reaction. So what happened is, this is the reagent given. If we use BD3, it's boronation of double bond. Actually, boronation is Markovnikov syn addition. Okay, actually it's Markovnikov syn addition, but the product will be anti-Markovnikov product because it will be BD2 and H minus. That is how, sorry, D minus. That is how it splits. Normally we use BH3. BH3 will split into BH2 plus and H minus. That is how it is splitting. So here hydrogen is leaving as an H minus species. So it's we'll get an anti-Markovnikov product, but actually the reaction is Markovnikov addition, Markovnikov syn addition. That's the stereochemistry of the reaction. Okay. So if you go for the anti-Markovnikov product, then what will be the anti-Markovnikov rule says hydrogen will go, Markovnikov rule says hydrogen will go with the carbon having higher number of hydrogen. Okay, here we have two hydrogens here. Here we have one hydrogen. Okay, so if it is Markovnikov addition, the hydrogen should come here in this carbon, but this is an anti-Markovnikov product. So deuterium should come here on this carbon. So deuterium will be here, BH2 will be here on this one. Okay, it's a syn addition, means both the reagent will add from the same side. Okay, so deuterium here and BD2 here. Okay, so that is how it adds Me on the back side and hydrogen on the back side. So this will be the product. Next, H2O2 NaOH. What happened is this will convert this BD2 to OH. Okay, so the product will be like this. Deuterium, OH, H, and Me. This will be the product. Okay, so the answer is, if you look at the options, you can say the answer is option B. Second option is the correct answer. Okay. Now question number 3. Question number 3. The major product formed in the following reaction. Okay, here you can see this is concentrated sodium hydroxide, and we have two aldehydes which is not having any alpha hydrogen. If a base like OH is added and an aldehyde without alpha hydrogen, the reaction will be Cannizzaro reaction. Okay, Cannizzaro reaction. So what is the mechanism of the reaction? So let's see how can we solve this. So the reaction will be like this. OH minus will attack here on this carbon. O minus OH H. When this minus charge come back, this H minus will be eliminated. H will be eliminated as H minus, and this H minus will attack on this carbon. So we'll get the product like this. And this will absorb the proton from solvent. Okay, so we'll get the product like this. Double bond OH. It will become OH. H. Okay, so this will be the product you will get. But you can say this is an acid and this is in the acidic medium, so this proton will be replaced by sodium, so the final product will be like this. Okay, so the answer will be, if you look at the options, you can say the answer will be option A. This will be the correct answer. The fourth question is like this. The major product formed in the following reaction. K plus O2 gives. When potassium react with O2, it's a direct question. We should know these things. It will give you KO2 as the major product. So this will be the major product. Option C is the answer. Question number 5. Which one of the following options is best suited for the effective transformation? So in this case, you can see once the HO aldehyde is converted to carboxylic acid, and we have OH here on the reagent, and it is not affected by the reagents used. Okay, we have substrate, we have OH on the substrate, and it is not affected by the reagents. So MnO2, definitely MnO2 will convert the OH, will influence the OH functional group. It will be oxidized. This is known as this DMSO COCl to triethylamine is known as Swern oxidation. And this is particularly for the oxidation of secondary alcohol to ketone. So definitely it is not used. This is also used for the oxidation of alcohols. You can see this is known as opener oxidation. This is opener oxidation reagent. So it was also used for the conversion of alcohol to ketone. And the fourth one is the best reagent for the conversion of this one. So you can say this is the answer. Okay, this is this reagent Ag2O plus sodium H4OH is used for the detection of aldehyde. This is the test for the detection of aldehyde. Aldehyde only react with this one. Okay, so the option D is the answer. Sixth question is this one. The structure of HCFA2 minus is. This is also a direct question. We should know the structure. HCFA2 minus. The structure of this molecule is square antiprismatic. Answer is option C. Question number 7. Among the following compounds that form the strongest hydrogen bonding is. To form strongest hydrogen bonding, the bond should be polar. Okay. So hydrogen should attach with a highly electronegative atom. In this options given, you can see fluorine is highly electronegative compared to all other halogens. So option A will be the right answer. Okay. Now let's move on to question number 8. Among the following, the biomolecule with a direct metal carbon bond is. That is the question. So this question you can see option. If you look at the option D, hemoglobin is given. Hemoglobin has porphyrin as the ligand. Porphyrin will be like this. Okay, 4 nitrogen attached to metal. Okay, actually metal is iron. So this will be the structure of porphyrin. Sorry, hemoglobin, and this will have bond like this. Okay, attachment like this. Okay. So, but actually the metal is directly attached to nitrogen only. In hemoglobin and chlorophyll also, it will be similar to this. The ligand is porphyrin. In chlorophyll, it is chlorine. That is the ligand. And the structure is very much similar to this porphyrin. Okay, nitrogenase also didn't have that carbon nitrogen bond. The answer is coenzyme beta. Option A is the right answer. 9th question. For the reaction H2PO2 PO2 minus plus or plus OH plus gives HPO32 minus plus H2. The right expression is given. Okay. If the concentration of H2PO2 minus is doubled, the rate is. It's a very easy question actually. The H2PO2 minus. Okay. This is here it is given in the right equation. So if you look at the power of this concentration of this H2PO2, it's 1. Okay. If it is 1, and then if it is doubled, the rate also will be doubled. Okay. So the answer will be option C. This is also a direct question. The nature of interaction involved at the gas solid interface in this option is. Okay. So the answer is option B. Option B is the right answer. Van der Waals force of attraction. Okay. So this is the right answer. This is all about question number 1 to 10. So we will meet in the next video by questions 11 to 20. Okay. See you. Bye.